Hello, and welcome to our AP review, topic 3.13, the Beer-Lambert law. The Beer-Lambert law has to do with visible light spectroscopy. In other words, passing visible light through a solution to determine the concentration of that solution. The Beer-Lambert law is dependent on a solution absorbing certain colors of light as it passes through that solution. Um, if you recall, dilute solutions that have color will be a lighter color than concentrated solutions. This light blue block here represents a test tube that contains a dilute solution, and this dark blue block here represents a test tube that has a concentrated solution that is the same as the dilute solution. When a solution is more concentrated, it is darker, and therefore the darker solution will absorb more visible light going through that solution. Um, in order to use the Beer-Lambert law to analyze the concentration of a solution, we have to use a color of light that will be absorbed by the solution. Not all lights are absorbed by solutions, and so it's important that when we're analyzing a solution that we pick a frequency of light that will be readily absorbed by the solution. So as light passes through the solution, some of it will be absorbed, some of it will pass through, and then we can detect how much light passed through the solution and see how much goes through the dilute solution versus how much goes through the concentrated solution. In our diagrams here, you can see that more light passes through the dilute solution because it is a lighter shade than the concentrated solution. Now, the importance of this is that there is a mathematical relationship between the amount of light that passes through a solution and its concentration, and that is the Beer-Lambert law. The equation for this is the absorbance of a solution, how much light is absorbed by the solution, is equal to the absorptivity constant, and we'll talk about that in a second, the width of the path that the light is passing through. In other words, how wide is the solution that the light is passing through, and the concentration of the solution, which will give the letter C. So A is absorbance, E is the absorptivity constant of the solution for a particular wavelength of light. B is the the path length that the light is passing through of the solution, and C is the concentration. Now, an important thing here is that for a particular wavelength, this is going to be a constant. Also, typically in any experiment, we're going to keep the distance that the light passes through constant also. What this means is that the absorbance is directly related to the concentration, keeping the other two variables constant. And so we can, if we do an experiment, we can measure the absorbance based on known concentrations, and then we can determine the concentration of an unknown solution based on a graph of the absorbance versus concentration for known solutions. So let's look at an example of this. Here is a graph where known concentrations, 0.003 molar, 0.006 molar, 0.009 molar, 0.012 molar, and 0.015 molar concentrations of solutions were created, and the absorbance of a certain wavelength of light was measured. Notice that as the concentration increased, the absorbance also increased, and that's because more light is absorbed as the concentration of a solution increases. So we can graph this, and it is a linear relationship. The slope of this line is going to be the molar absorptivity constant times the path distance for the solution. That's not very important. What is important is that it's a linear relationship and that concentration and absorbance are directly related. What this allows us to do is now analyze some unknown substance of our solution and figure out the concentration of any unknown concentration based on analysis of the absorbance of that solution. So let's say we had some unknown solution and it had an absorbance of 0.6. So if the absorbance of the solution that we do not know the concentration of had an absorbance of 0.6, we simply go across on our graph until we hit our line. Then we go down and we find out that if the absorbance is 0.6, then the concentration of that solution is 0.02 molar. And that's where the Beer-Lambert law's power is it allows us to use known concentration solutions to determine an unknown solution's concentration. Again, we would have to do an experiment where we measure the absorbance for known concentrations, and then we can determine the concentration of an unknown solution. It has to be the same solution, and you have to use the same wavelength of light passing through it. If you change the wavelength of light, then all of this is not true anymore, because the Beer-Lambert law is true for a specific wavelength of light. Another important point about the Beer-Lambert law is that this will only work solutions that have color. If a solution is colorless, then no light will be absorbed by the colorless solution, and you cannot use the Beer-Lambert law to analyze a solution. I hope that this helped you understand the Beer-Lambert law a little bit better. If you have any questions, please let me know, and good luck in your studies.